So I'm going to talk about a tool that I made. And I think, let me make sure my microphone's the right one because it doesn't sound like it's right to me. Does it sound like I'm distant?
It sounds okay.
Sounds okay. Okay. Does that sound much worse?
Can you speak a little
Yes,
more?
I'm speaking more.
That
Sounds same.
sounds worse.
Sounds
Yeah.
worse. Excellent. That means I'm using the right microphone. um, I made a tool called undataclass that takes a data class and converts it into not a data class. So you can see here's the output. So it made this class here using func_tools total ordering. It's got this dunder match args, dunder slots, dunder init, dunder repr, dunder eq, dunder lt, all these little methods in here. And what it started with was this class. And the reason it's so big is this, we started with a frozen data class, and frozen data classes, that's where you really end up having lots of methods. Dunder set adder, dunder del adder, things get really complex with frozen data classes. Now, I'm not going to talk about this tool per se. Rather, I want to talk about something I learned while making the tool. I made this not because I don't like data classes. I love data classes, but I teach Python through Python morsels, as Jeremy mentioned. And Jeremy also gave me the best testimonial I could get during a talk. I'm apparently one of the best Python content creators out there, according to you and your website, which I appreciate, Jeremy. And I'm excited, by the way, for Jeremy's tool. But I made this to teach data classes. If you make a data class, often the next question that comes up is, what is this equivalent to? What does this really get me? So you make a data class, you convert it to not a data class, you can see what you'd have to write instead. You know, what is the equivalent code? And sometimes it's not too hard to write something, an equivalent data class without a data class. Sometimes it's pretty tricky. So the tool uses a single function called undataclass that accepts a bunch of Python code. And it uses the AST module that's built into Python, stands for abstract syntax trees, to take the code and parse it. Now that's the magic that I don't understand. We don't have to understand. It takes the body there, which is essentially all the nodes at the top level of that module, import statements at the beginning, class definitions, function definitions, whatever's at the top level of that module. It loops through those nodes, and then it uses Python 3.10's match case. This is where things got interesting. I didn't use match case at first. I used if, elif. And then at some point, I realized the code that I had was really, really complex. So I want to show you an equivalent call to, let's see, not this one here. Here we go. So this code here, if I used an if elif statement instead of this match case, it would look something like this, where we've got if is instance and this, if is instance and this, if elif is instance, and then we've got an any. Instead, we have case import from module equals data classes. We're able to make an assertion about not just the type of the object, which is this AST to import from, but that it has a module attribute that's equal to the string data classes. And same over here. So we do both of these assertions in this if statement in really one much easier statement in the match case. Now, this wasn't the biggest win from this match case. A much bigger win was up here, right here. So this was a very big win. So this particular match case, now this case statement is very hairy. I wouldn't say this is good. This is just complex by nature. It has to be complex. It's not great because we're saying let's match an annotated assignment where the value is a call, a function call, a class call, some kind of call. And the thing that we're calling that function is either the name field or it's data classes dot field. So it's one of those two. And it's just very complex. The thing is, this is much shorter than if I had done the same thing with an if elif statement. So with if elif, I'll show you the equivalent. Copy paste it in here. So instead of this match case, we'd use this if elif. Look at this. So this is the equivalent, which is, oh no, that's not the right one. Let's see, field. Here we go. This is even worse. So it's that second case that we had. Let me go back to that case there. The second case statement, this is the really hairy one, the particularly hairy one in here. If we replace this match case with an equivalent if elif, the second, or really the first elif, this is the equivalent. It's much, much more complex because we're asserting that the thing we have is an instance of call. Okay, great, it's a call. That means it has a func argument. If that func is a name, well, that means name has a ID, so then it's field. Or if it's not, then it's an attribute. Okay, if it's an attribute, then we need the value to be a name and the ID to be data classes, the attribute of the value to be field. So it's just really complex. And if we don't do it this way, we end up raising an exception because we have to make sure that the type is actually correct. So by nature, what we're doing is a very complex matching operation. So I accidentally discovered the perfect use case for match case. Now I do want to note, this is Python code that parses Python code and matches that code somewhat sloppily against particular things that we're looking for. And it does it recursively, or it could be doing it recursively. It doesn't necessarily have to do it recursively. Matching tree-like structures, something, for example, like something that's parsed, or maybe a JSON object, something that's deeply nested, and you're doing it recursively, or matching the types of things. That's what match case is really, really good at. Besides that, I wouldn't really use match case very often. I do want to note this though, because if you're ever implementing a template library like Django's template library or Jinja 2, if you're ever implementing something that parses Python code, if you're implementing something that is parsing JSON that comes back from an API, and it's a very complex JSON structure that could be one thing or another thing, and it's just a complete mess. It's almost like you're writing parsing code at that point. That's when you might reach for match case. So that's pretty much what I wanted to show. I mean, there is a little bit more in here, but it's, you know, there's just a couple more match case examples essentially. And I could show you specific examples of what match case can do both in this script and outside, but I want to open it up to questions. Do you have any questions either about this strange tool that I made or more specifically about match case, which you honestly probably shouldn't be using, but I do want you to know about it in case for some reason you ever end up in this world of parsing land. If you're parsing something, try out match case and see if it improves your code. Any questions?
Very quick one. Which version of Python was match case added in?
Python 3.10, so the latest and greatest, unless you're on the latest beta version of Python, which you shouldn't be, then yeah, you have to be on Python 3.10. And by the way, this case statement, I didn't mention this, but it is not Python code per se. It's Python-ish, but there's syntaxes in here that only exist in match case land. For example, defaults, which is actually a dictionary. Oh, no, actually, this is Python syntax. So it's a 3.10 syntax. So this one is not. AST.attribute, calling that class, which should make a new instance. It does not. Pipe, which is saying or AST.name. So this is essentially the same as elif is instance of, you know, this node thing of either of these two things. This is not valid Python syntax, though. This is match case syntax. So this case statement has its own special syntax that only works in the context of case. I see David making a face. That is exactly the reason that this was a controversial feature when it was added to Python 3.10. And it's the reason it's so powerful. It's the reason I can write such succinct code. That weird pipe I had up there, it was doing a lot of work, wherever that very big case statement was in my code. Other questions? Here it was. That was doing quite a bit of work. And actually these attribute lookups are doing quite a bit of work as well.
So
Yeah.
since it's not true Python, how does someone looking at these snippets know that these relate back to like use, you know, this module or use that, like the AST dot? Or
Yes, yes, it is true Python in the sense that the names that are used in here all have to be valid names, with some big exceptions. I can say, for example, ID equals, I guess I'd call this func ID. This is not expected to be a valid name. This is actually an assignment that happens to capture func ID to say whatever this func thing here is, take its name, take its ID, capture that into the variable func ID so that inside the case, I can actually use that func ID variable. So that's weird. However, AST.name, this has to be a valid thing. Func has to be an attribute of call. That's actually that dunder matchargs thing I briefly kind of showed you by accident before. And then AST.anAssign, it has to have a value attribute that's in that dunder matchargs thing. And it has to be an instance of call. So really it's a mix of, this is valid Python code, but very, very simple Python code combined with these very, very strict little things that we can use here. The pipe operator, and assigning to attributes. So to answer your question, kind of the same way you'd know with Python, that it, wherever there has to be a valid name, has to be a valid name. Wherever there's an assignment, whether implicit or not, it's going to be an assignment.
This might be a simple question, but at one of the Saturday meetings way back, I was asking about the case statement that Linux Bash does. Like if you have a simple online menu, you know, press B for section B, press X, and then you do case in, and someone's like, no, you have to just use, you know, if, and nest them. Can this be used for that kind of case handling?
Ish. So a lot of people compare this to switch case, which is from Java World, JavaScript, C, C++, similar to case and bash. I wouldn't use it for that, mostly because, as I showed you here, this is a complex syntax. It can, you know, it's more complicated than a simple switch case. Therefore, I would probably either still continue to use if, elif, or honestly, better yet, I often would use a dictionary, if you can get away with it, that maps keys to particular values to avoid the if, elif. So let me see if here's kind of an example. Defaults equals this thing. Oh, actually, that's not a good example because I'm not actually using defaults except as a dictionary. But if I was saying, you know, if I had one thing that was, maybe, you know, 0 maps to the number 0, 1 maps to the number 1, and I had an if elif that was if the string equals 0, then use the number 0. If the string equals 1, use the number 1. I could then replace it with the dictionary lookup, mapping a key to a value. So I would do one of those two things still, even though you could actually use match case like a switch case statement, probably. Well, almost certainly, actually. However, if you do use it like a switch case statement, you're going to get away with it. It works as long as the other people on your team are okay with it. It's just that for longtime Python developers, will probably look at that and go, oh no, why are you using this new syntax I have to learn now? Other questions or thoughts? Oh, the tool, by the way, is not on the Python package index, mostly because once you put something on the Python package index, people start using it. I don't really want people to use this for anything because it's very sloppy code. It is meant to be sloppy. If you have a pull request, you're welcome to add a pull request. I've thought of reserving it on the Python package index just so that I can put it on there, but I honestly don't think I'd ever want someone to say pip install this because this doesn't seem like a good idea to actually use in Python code. So if you want to use this, it's at github.com/TreyHunner/undataclass, and there's an undataclass.py file. There are tests for it that I just run manually when I run my tests. And you can copy paste that code. It has a license in there. So not on the Python package index, but it's a single file. You can copy paste it.